Hey folks, Eric Wooldridge here of the Additive Guru channel. Today's little exercise is going to make a part generatively to solve a problem. And this particular problem is a monitor stand. Or more accurately, we have a monitor, this AOC here. Pretty nice little monitor, curved, that's kind of cool. And you'll notice here that the stand includes these two legs and the vertical component. It actually bears at that point and that point and that point when sitting on a desk. The problem that we have is the monitor needs to be further back and we are running out of desk in which to actually make it sit. So with that in mind, what we're going to do is we are going to create, so if right here is the edge of the table, what we're going to do is we're going to create a stand or a component that we can attach to the back end of the table or desk so that the rear stand here component can slide out and yet the two legs will still be on the table and balanced. So essentially what we're shooting for is something that will connect to the table above and below. So we'll screw it there and screw it there, and there'll be a platform that allows the actually probably a little bit more like this. Connect to the table here and here, and we'll slide out horizontally with the same surface as the top of the table. So that's kind of what we're going for, is to line that up with that and then let generative take it from there. So we'll probably screw from above and below, and then generative will bear the weight, and that way this thing can slide out. So to make the part, it's going to be a simple process of sketching out and extruding. So what I've done right off the bat is I started off by creating this particular cross section. Now you'll notice that I have a lot of little rings here, and let me just go ahead and pull the sketch up so you can see it. And before we get too far into it, let's just break it down in what you're seeing. First, we are having an attach point here and attach point here, and this line represents the actual edge of the desk. So we plan on using screws right there and right there from above. And I've added these circles around that to obviously be cylinders for the screws to penetrate through and into the desk and actually hold. So there will be anchor points. Then we actually have the slide, which is represented by this. And when I say slide, it just means it can slide out. So if the table stops, then this slide starts, and it's going to be roughly 30 units wide, roughly 60 units out from the desk. And we have added on an extra edge around it to form a sort of a lip so that the stand can't slide out. So if here is the desk, here is the start of our landing slide, the monitor stand could be right here, and we want to have a little lip to keep it from sliding out and sliding off either direction. So that's what this outline that you see is right here, this 4-unit offset. It wraps around, and I just did a nice little rounding here to finish it off. So if you want to, you can take a screen capture of this and get some of the dimensions if you want to follow along. The basic sizes are pretty easy to work with. And I'll zoom in just a little bit there for you to see. So the opening is this area here, here, and here. It's 30 wide. It is a 40 or 4 millimeter offset circle, and then I just drew lines straight down to this imaginary edge of the desk, and then placed my screw holes to either side, making sure that they didn't line up with the actual slide area, because the monitor stand is going to slide through this area. So I had to make sure that they are away from it there and there. So I set them apart about 25 from a center line that I just drew a center line with a construction line straight down, and there we go. So that was the overall process. What was neat though is that you're able to, with Fusion, to do multiple extrusions off the same sketch. So let's take a look and see how it works out. Again, you can capture this in screen capture if you want to, and then you'll know what to design it with. Alright, so let's finish. And I will pull my slider here so we can see the extrusion. And I'll shade it up for you. So what I did was I first extruded the things that were going up from the desk. So again, if this is the surface, this is the edge of the desk, we've extruded up our cylinders, and we have extruded up the lip and the catch, but we didn't actually extrude the actual slide. That needs to go down, and I don't want to extrude that at the same time. So what I did was I extruded up first, and then you may notice that oftentimes after you extrude something that Fusion will turn off the sketch you used to create it. Well, I just came in here, expanded this, turned it back on, and did another extrusion. You can see that there's actually two extrusions right here. This extrusion was based off of this area, this area, this area, and this area. And that's what was extruded down. And so I extruded it down roughly, I think 4, we'll check it real quick to be sure, maybe 5. Yep, a -5. And I extruded vertically these, a value of 8 up. So we have 2 cylinders coming up 8, a lip around the slide up 8, and then we turned around and extruded down 5, the slide itself. And you also notice that I went ahead and extruded all the way from the edges of the actual lip. So I included in this extrusion this entire zone of the bottom piece, because I didn't want to just have, if you only extrude up to like this area from here to here, you won't get everything. So kind of watch that. So if you want to, you can go ahead and pause the video and kind of recreate what I've done, and we can go on from there. All right, so the next thing was, well, how do I create the cylinders down below the table or the desk? We're looking at it from the side, and there is the slide. This is the lip to keep it in place. Here's our top cylinders. Well, what about these down here where I'm going to screw into from below and above? And I don't want these to line up either, because I don't want the screws hitting each other. And we're assuming that the thickness of the desk is 30 millimeters. So how do I create those? Well, it's a real simple process. You're just going to do a construct, an offset plane, and you're going to choose a surface to offset from. I actually started from the 0 point on the XY axis, or actually 0Z, you could take it that way, and I extruded, or I actually created an offset plane down below, which is turned off right now. There it is, you can see it, and you can see that it is below this, and it is a value of 30 millimeters down. And I use that to sketch this. And these. So I did a quick sketch. I'll show you the sketch too. Gotta turn it back on so you can see it. Turn the other ones off. And I just basically sketched out 2 circles. I did line one up center with the other one from above, but just slightly offset so they didn't hit each other. And this one I just randomly sort of placed in this general zone. I don't have to worry about the monitor slide being in this space because this is below the desk. So I can kind of just grab and pull these things wherever I want to and place them. I set them to be a 5 diameter opening with a 14 diameter overall thickness, and then extruded them, I think 12 or 14, something like that. 10 actually, sorry. So 10, and there we go. So a 5 opening, 12, 14, and then 10 down is the cylinder that was created. Then it was just a matter of going through and adding a couple chamfers. Chamfer here and here, and then a chamfer there and there, so that whatever kind of screws, especially if I end up using something like drywall screws or something, they sit down nice and flush against the surface of the cylinder. And then the last step was actually do, and I think the chamfer was like a value of 2 or 1, looks like 2. And then I did a fillet to actually round off the edge there and there, and down below too, just to kind of smooth our slide out, and the actually not really the slide but the actual lip, just kind of smooth it out to make it a little bit more interesting. So there was the part creation, and overall dimensions are mostly controlled in the very first sketch, because that controls the overall slide, the 2 cylinders, their location from the center of the slide, both to each side of the center line and also from the edge of the table down. And then again, the actual slide is about 60 to this point, an extra 15 top, and I just drew a circle over a diameter 30 to make the slide work. And a slight lip of 4 offset there. Okay, so that is the creation, and why don't you go ahead and pause the video and kind of recreate what I've done. And if you play with it a little bit, you don't have to have it exact, but it's just something to get going with. Go ahead and pause the video and make this now. All right, so the next step, of course, would be to switch to generative. And obviously these creations are part of my preserved geometry. So I just click on the preserved geometry, tell it to preserve those, and we're good. And then I went about creating my obstacle geometry. Now this I just went to edit model. And I designed in a few things. Let's turn it on so you can see them. I extruded, let's see if we can pick some of these out. And so body 6 is the one. Body 6 was just an extrusion straight up from the surface up this way. And looks like body 8 was a representation of the table itself, 30 millimeters. And that was a pretty easy thing to extrude. I just went straight down from the underside of one of the cylinders, made a box, and extruded down. And then I just came out to make sure that with body, looks like, where it is, body 7. Body 7 would just be an extrusion straight out the back, so that way nothing blocks the monitor sliding into my slide off the back. So I had to make that so that all this area was clear. Then it was just a matter of going through and adding connector obstacle for the actual holes of each cylinder. So all these came straight up, and these came straight down. I had to do one for each one. Now, one thing I will point out, when you do a connector obstacle, you can make it bigger than the hole itself. You'll notice that these are actually larger than the hole, because it doesn't really matter as far as generative is concerned, even though it interferes with what's going to be preserved. So it's okay that you make them bigger, and I typically do that, especially when I do chamfers, so that it doesn't try to get into that chamfer area as well. So that was the creation of those features. Now, one of the things that do keep in mind when you do these kind of creations, you have to make sure when you extrude them that you set them as new bodies. Do not set them as join. Otherwise, they end up joining your stuff that needs to be preserved, and that causes you problems. So make sure that when you extrude them, set them as new bodies. That way you can come into obstacle geometry, click on the pencil here to add those features in. So you can see the green is the 4 cylinders, the lip, and of course the slide itself, and the rest is obstacles. Now, as far as my objectives were to minimize the mass, safety factor of 2. We can play with that based on the generative results. That's probably a little bit higher than it needs to be given the loads I applied. Manufacturing, of course, was set to nothing but additive. You can see these are unchecked. And the study materials were set to ABS plastic on the first run. I could have chosen other types of options. Typically, when we get into issues and things aren't working the way we want them to, we will switch this to a different type of plastic, maybe a polycarbonate, maybe nylon, just depends on the situation. And we start off with ABS plastic because it's pretty simple and easy to use. And then there was, of course, the load cases. And the constraints were actually fairly easy. The constraints were nothing more than just clicking on the inside surface of the holes, and all 4 of them, and telling them to be fixed. And then there was the advantage of actually just applying the load. Gravity loads are fine. Clicking on the surface of the slide and applying the load of 200 newtons. That's heavier than the actual monitor would be, but we figured we'd throw in a little extra bump in case something was dropped a little bit more than necessary. So this is already a little bit more weight than is actually going to be applied. That's why we can go back and change that safety factor if it's a little bit too much overkill. But we can get into that later. So we have our loads, we have our constraints, we have our study materials selected, our manufacturing process, we know what our objectives are, we have our preserved geometry. We would click on this and do the pre-check. Then we would do a quick preview to make sure it's going to work, and then of course we would do generate, and that's what I'm doing now. So why don't you go ahead and pause the video, walk through those steps. They weren't too bad. You can always rewind and go through them again, but go ahead and pause the video and get to this point. Alright, so the next step, of course, would be to go to our generate, and we're actually still generating now. Sorry about that. But you can see these processes. Oh, we've already got converged. So let's take a look and see what we have. and this might make give me a good reason to go back and make some changes. So pull this first one up. We say we hit our mark in iteration 28, and pretty interesting. You will notice some kind of weirdness happening right there. Get a little hollowing out. That's kind of interesting. Although it stays outside of the zone it's not supposed to be in. It did sort of wrap itself around the cylinder, which I guess is okay. Apparently the cylinders weren't enough, and you can see it's kind of added that in. So that's one option. Let's take a look at the other one. I'm thinking we could probably reduce the safety factor a little bit, or maybe upgrade the material a little bit, get a little bit different result. I think we could probably I think we have some potential material efficiencies that we're not getting at this point. You see this one, its creation, a lot of thickness right here. Kind of the same, not a whole lot of difference than the other ones, but a little bit more hollowing out. Let's see the third one. And I only set it to one material, and so you can see here a little bit more hollowing out, a little bit more strengthening in this area. Odd little thing going on there. That's all right. So pretty interesting results overall. So one thing that I would do and say, you know what, this is cool and everything, but I'd like to explore a little bit more thinning it out. And I would probably go back and change my safety factor back from 2, maybe down to 1.5, maybe 1.2, and then maybe change my material to a polycarb material, because we can print in that all day long, and sometimes the ABS is just a little bit too low in performance for us. So those are the initial results. I'll do one quick change, finish my outcome view, finish my Explorer, and I may just go back in and change the objectives real quickly from a safety factor of 1.2 to 2.0 to 1.2, and then maybe change the study materials to something just a wee bit stronger that we have access to, maybe a polycarbonate. I think we could do nylon or PC ABS that you see here. Grab it up, drag it there, and then right click on this one and say delete. So our polycarb will probably give us a little bit better. That safety factor reduction will help us out. I could check the previewer again, but we kind of know everything's good from the last run, and because they did converge, and we can kind of see how it forms out, just so you can see that process. And that's probably good enough for us right now for you to see. It is kind of forming around where we want, and I'll just hit generate. And yes, I want to continue, and we generate the study. Okay, so from here on out, it's just doing some tweaks and doing some adjustments until everything is just the way you like it. So thanks for watching. What I recommend you do is go ahead and generate this yourself and play with it a little bit. See if you can find ways to thin it out just a little bit more. Get it a little bit more dialed in. Switch materials perhaps to the, maybe you can try the nylon out. We found it gives a pretty good result. And also maybe adjust your safety factor. If you want to, you can go actually find out the exact weight of the monitor. We were using like an AOC 32 LED curved, and you can see how much it weighs, and then actually find out the true Newton value there. Maybe just do a little bit of safety factor, maybe 1.2, 1.4, and then kind of try it that way. So play around with it. Thanks for watching. Check out some of our other materials, social media stuff, other videos, and make sure to subscribe to us to see more cool stuff. We'll see you.